In exercises 11 through 14, cards are dealt from a full deck of 52. Find the probabilities of given events. So 12, part A, the fourth card is a king. Part B, the second card is king given that the fourth card was a king. Part C, the fourth and second cards are both kings. Then part D, draw a tree diagram illustrating this. Let's first look at the part A. Page 315. Problem 12. Part A. First, let K1 be the event the fourth card is a king. Let me just write first is a king. And we need to find the non-conditional probability of this event, P of K1. We know when we draw cards from a deck, n of s is equal to 52. Then this is equal to n of K1 over n of s. What is n of K1? How many? 4, right? We have the 4 kings available. So this is equal to 4 over 52. And it cancels the common factor 4. So you have 1 over 13. So part A is very simple. Now let's look at the part B. The second card is a king given that the fourth was a king. So in part B, let K2 be the event second is a king. So we need to find the conditional probability of second is a king given that the first was a king. So this is the conditional probability of K2 second is a king given that the first was a king, that is K1. Now tell me, when you draw the second card, how many cards available? 51, right? You already drew 1 card in the first draw, so only 51 cards available. Now in the second draw, how many kings are available? 3. Since you already drew the 1 king in the first draw, right? So 3 over 51. And this is this conditional probability. And you cancel the common factor. So you have 1 over 17. So this is the part B. Now let's look at the part C. Part C, the first and the second cards are both kings. So this one is a little bit hard. Actually, for this part C, we need to use the product rule to find this probability. Part C, so we need to find the probability that both the first card is king and the second card is king. So that is the probability of K1 intersection K2. And we may rewrite this as P of K2 intersection K1. Actually, K1 intersection K2 is equal to K2 intersection K1. And then, in our formula for the product rule, we have the P of A intersection B, and this is equal to P of A given B times P of B. Then you may treat this as your A and treat the K1 as your B. Then by applying this product rule, you have P of K2 intersection K1, that is same as P of A intersection B, is equal to P of A given that B, so that is P of K2 given that K1 times P of B, that is P of K1. And we already found these two probabilities in the part A and part B. Let's go to the part A. P of K1, 1 over 30. P of K2 given that K1, 1 over 70. So now the first one is 1 over 70 and the second one is 1 over 30. And you multiply them, you have 1 over 221. And this is approximately equal to 0.0045. Now let's look at the part D. Part D, we need to draw a tree diagram illustrating this. When a probability problem involves more than one stage, then we need to draw a tree diagram to illustrate the relationship between the stages. So now, let's look at the part D. We try to draw a tree diagram. And first, we begin with the root of the tree. And we use one branch to stand for each event. So, in the fourth stage, we have only two outcomes, two events. So either the fourth card is a king, so we may write a king here, or the fourth card is not a king, we use a K prime. And then we label each branch by the probability of the event it stands for. So the fourth card is king. In the fourth draw, we have the 4 kings available, and totally we have the 52 cards in the deck. So this is 4 over 52. And then we have the 48 non-kings available, right? You have the 52 minus 4, you have the 48. So the probability that the fourth card is not a king is equal to 48 over 52. Okay? So this first two branches stand for the non-conditional probabilities. Then, based on the result in the first stage, we look at the result of the second draw. So if the fourth card is king, then we may also have the two results for the second draw. Either the second draw is a king, or the second draw is not a king. So it's K prime. Now, this second branch, okay, this guy and this guy, stand for the conditional probability. So now, this one, if the fourth card is king, then what is the conditional probability of the event the second card is a king? How many? So we just got this in the part B, right?